wireless mesh networks. First of all, I would like to thank the Syrian Society again for helping us host this course. I won't go too much into what's going to happen. Mr. Bekawi is going to offer this course in a few moments. Just a few words about the certificates. If you attend any of the sessions we have made and you ask for a certificate, it will be offered for you. And right now I'd like to invite Bekawi to start the course. Yes, sorry. At the end of the session, we'll have a Q&A section where you can ask any questions or anything that you want to know. We'll also post all the recordings on our website. We'll send you a link whenever they're uploaded tonight, hopefully. All right, thank you, Mr. Bekawi. Please start.
All right, thank you so much, Amina, our software lead. And big thanks goes to the Syrian Society and the Syrian Society President, Abdulrahman Alsalkhadi, for making this happen. Big thanks to you guys for being with us today. And I hope you find this useful and joyful. All right, today we'll be talking about the wireless mesh network, but not the non-wireless mesh network. It is going to be the painless way. So what is a painless mesh network? Actually, it's an open source library specifically written for ESP8266. It is painless because it is auto-configure and easy, really easy to set up. All the nodes in the, and actually every module or every ESP8266 is considered to be a node, is called a node. Every node is can be either an access point, or maybe let's say the router, or station, or as if you remember from past workshop, we called them server and client. Every node can be either server or client. All of this is going to be handled by the painless mesh library. We are not going to do all of this. The mesh network is actually a star network, but no central access point. Every node is aware of the whole network topology. Every node is going to tell the other nodes about the nodes that directly or indirectly connected to it. Okay, so the typical diagram of a painless mesh network, if you can see in here, we have each green dot in here is an ESP8266 module, and they are connected through only a single line or single path. If you think about the connection between each node, you will find each node is connected to the others with only a single path. For instance, if I want to connect this node with that node, I have to go through this path. So what's so-called the cyclic path is not going to be present here in the painless mesh. However, it is present in the known mesh network. So why do we use mesh actually? The development of Internet of Things, we have sometimes we have a limited number of nodes that could be connected to the internet or the routers. The normal routers usually have maximum nodes to be connected to it of 32. So imagine you want your application to extend to 100 nodes maybe. So what you can do actually is either get something called a super router, or you create a mesh network. So let's go and see what this mesh network is going to be. And here I have taken this figure from the ExpressF company document. I will be sharing the document with you at the end. In this cloud, you will see the mesh network, same as we have seen in the typical diagram. These nodes can be up to 87 devices, okay? And the connection between each node can be 100-meter long, and I think as long as they see each other, line of sight. And you can have the hierarchy up to 5 level, like this one is connected to this one, then to that one, then to that one, then to the main one. As we said, the painless mesh is going to consider all nodes equally, but you can take only one node and connect that to the Wi-Fi. You use some bridges or something to connect this to Wi-Fi, and this is going to take whatever received by this Wi-Fi and send it to the whole network, or maybe take information from the network and send it to Wi-Fi. Okay, so the type of messages used in the mesh network, they can be either a single message or a broadcast. The single message is actually a point-to-point message, like you send message from one ESP8266 to another module, and the broadcast is sending this message to every node in the network. Remember, the mesh network doesn't use Wi-Fi, okay? How do we distinguish between these nodes? Actually, we can distinguish them by using a 32-bit number, which is the MAC address of each chip. Each chip has its own MAC address given to it by the manufacturer. The message type used, or maybe let's say the data type used in messaging, is actually of type JSON, which is for JavaScript object notation. This JSON actually uses human readable text to transmit or receive data, and it is also serializable. It also uses the form of value key pairs. If you are familiar with Python, you know the dictionaries in Python. They act actually almost the same. Okay, the model used in today's workshop, we will be using the broadcasting messaging. We will have 3 nodes. Every node will broadcast a unique message with some values in it. And then the receiving nodes, like every node will be sending and receiving, except maybe for one. The receiving part of it, we will extract the information that we are interested in only. Okay? So let's go and talk about the hardware a bit. And for this, I will also show you the hardware connection, as some of you suggested. But I need to connect my phone. Just bear with me. Okay, let me continue, and then at the end I will show you the hardware connection. So for the first node, if you are not familiar with electronics or maybe breadboard or prototyping, and this side from F to J, this side, each row is connected together. Each of these 5 points are connected together, and same from A to E. If you go from row to row, each row is connected together horizontally this way. But for this side, only the vertical are connected. For instance, this blue one, they are all connected together, and the same for this red one. So I'm connecting the 5 volts and ground, and then share this 5 volt and ground to the other side to use them from both sides. I have also the digital connection pin going to a resistor, and then this resistor is going to an LED, and the LED is going back to ground. We have a potentiometer. Actually, this potentiometer is nothing but a variable resistor. You connect it to a potential difference, and then take this middle pin to analog pin to read values. And whenever you scroll this, you will find different results. So this is the first node, and this is the first one we will be coding. And then going to the second one. Okay, going to the second one, we will have the same thing. All of them will be connected to LEDs in the same way, but the difference here, we have a push button instead of the potentiometer. We'll be reading this button state and sending it to the whole network. And then we go to the third one, which is connected to only an LED, and we'll control this LED using the information sent by the other 2 nodes. So before we go and code, let me show you the hardware. Just bear with me. Okay. All right, let me share the screen with you. Okay. Now I have all of these three nodes. This is the first node I've talked about. I'm using the WeMos D1 Mini. I have this potentiometer. I can adjust this to get different values. And I have this LED connected through a resistor to the digital pin 1. I'm using the 5 volts and ground from here to go to the potentiometer, and also I'm taking this common ground to take it back to the LED. For the second one, this is the third actually, the third node. I'm taking the ground there to connect my LED through a resistor to a digital pin, and in my case it is D5. For this node, the same way I'm taking this ground for the LED through a resistor to digital pin 5, and I'm taking digital pin D3 going to the push button, and then this going back to ground. The same as you saw in the connection in the slides. So this one will be sending the ADC value read by this potentiometer, and that one is going to be sending the button state and taking these values. This button state will control the LED of this one. This value will be sent to the entire network, the same as the button state as broadcast. This one is going to take both readings, or maybe one of them at a time, and control the LED state in there. This LED, I'll make it blinking whenever we start sending and then we finish the sending part, and you'll see this is going to be blinking super fast. Okay. So now let us go to the Arduino IDE. Let me open it up. Whenever you have questions, guys, please don't forget to leave them in the chat session at the end when the Q&A session comes. We will look and try to answer them. Okay, here's the code. All right. Same way as before, we will start from scratch, doing everything. Let me save this and say it's the first one. Okay. So for the painlessMesh, we need two libraries. One of them is basically the painlessMesh library, and the second one is going to be for the JSON data type, and it is called Arduino JSON. Whenever you try to include these libraries, if you are not having them, you might go to Tools, Manage Libraries, and search for them and download them. If not, if you couldn't find them in the Manage Libraries, you might need to go to the GitHub and clone that folder. So the painlessMesh, we simply say painlessMesh.h, and we include the Arduino JSON.h. Actually, painlessMesh itself, maybe I think it is using the Arduino JSON.h library, so it is defining the Arduino JSON, or maybe vice versa. So this exact order has to be used. Otherwise, you will have an error saying that you have multiple definitions. So let me show you what I mean. I'll try to compile this code and see what output we get. If it is the exact order, the correct order, maybe I missed them. If it is the correct order, then we will have no errors. But if it is not, then we will see some errors in here. Usually when you compile codes for ESP8266, they will take longer time than Arduino owners. Okay, now we have no errors. We are done compiling. Let me try to reverse the order and see what is the output. Okay, you see? Now in here in the error, it says, if you scroll up, multiple libraries were found for painlessMesh, multiple libraries were found for Arduino JSON. So remember, this order has to be exactly the same. In this way. Okay, enough talk about the library. For the painlessMesh, in order to make it able to communicate, we need to define 3 parameters, and these 3 parameters have to be exactly the same for all nodes in order for nodes to know that they are connected through the same mesh network. And this, I call them the mesh credentials. It's similar to Wi-Fi credentials. You'll define an ID, and this ID could be anything, literally could be anything. I'll just call it maybe Aquabotics. Okay, then we define the password, and also the password could be anything. I'll simply call it the character squared, which is the project we're working on. And then you define something called the port. Usually the port is an integer number, but it is preferred to have the port as big numbers, and I will just leave it for the default one. It is 4 5, and then we are good to go. Remember, this has to be, okay, this one has to be same for all. Okay, don't forget this definition. These definitions has to be the same for all. Okay, now for our first node, we know that we are connecting a digital pin to an LED and an analog pin to a potentiometer. Let me define these. Okay, maybe a bot to A0, and define an LED to, I think it is D1. Yeah, it is D1. So now we need to set up our mesh network, or maybe mesh class. Before we go into this, we have something that is really useful for Arduino coders, not only for mesh networking. And basically, it is the parallel programming. If you are a computer engineer, then you know exactly what parallel programming means. It is basically threading, multi-threading, or you have different processes running at the same time, and this is so great to have for an Arduino, for a chip that doesn't cost more than $5. And this is so powerful. But in order to be able to do this, we have to have something called the task scheduler. This task scheduler, you will define your tasks and then attach these tasks to the scheduler, and these tasks will be running at the same time. Why do we need to define this scheduler? Actually, the painlessMesh is using this scheduler to synchronize the connection between other nodes in the network and allow you to have your tasks done in parallel ways. We have to use the scheduler for the painlessMesh, but it is more useful for other Arduino applications. You can use them for any application. It's only about parallel programming. So to start off, we use the maybe I'm missing, yeah, scheduler. We use the word scheduler and then simply give it any name. I'll call it my scheduler. Okay, and then simply we add the painless mesh class. I'll just call it mesh. You can call it whatever you want. Now we need to define our tasks. So the only task we have for this node is sending the value of the ADC. And to do this, we use the task class. Excuse me. This task class use 3 different parameters. First, we need to give it a name. I'll just simply call it a send task. The first parameter of this send task is actually your interval. And this interval is in milliseconds. But if I want to explain this interval much better, I can. Sorry, guys. Do you hear me?
Yes, we can hear.
Okay, sorry, it was about the internet connection. Okay, what was the last one you have seen? Last thing I explained. Can anyone tell me?
It wasn't after you define my schedule.
Oh, okay. I'll go back from there. Sorry for this. Do you see the code now?
Yes, it's clear.
Okay. So for the scheduler, we define our scheduler in order to do the parallel programming, to enable the parallel programming, and it will be used by the painlessMesh. And then we can add our tasks in here, and then at the end, attach these tasks to the scheduler. So the first task I wanted to have is the send task, and it is going to be the only task I need for this first node to send the values of the ADC. So this task class takes 3 different parameters. The first one is the interval, and this interval is in milliseconds. Okay, and to have a better idea of intervals, if you are familiar with Arduino coding, if you go to your loop in the beginning or at the end, you add a delay to it. So your loop don't go back. Sorry. Your loop don't go back unless you have this amount of delay. It is the same thing, but it has to be defined in the task declaration. You can use numbers like maybe 500 to mean this is half a second. This 500 is in milliseconds, or you can use the definition given to the task by called task second. And this task second, if you serial print this one, you'll find its value to be 1000. If you have 1000 milliseconds, then it means 1 second. And then maybe if you want 10 seconds, you multiply with 10. If you want 1 second, you multiply with 1, or just leave it as it is. So for now, let's define this as this way. So whenever you want to change this number of seconds or the delay, you just change this number, okay? The second parameter that the task class takes is the number of iterations. How many times you want this to be happening? For me, I want this to be happening all the time. Then I can use the definition called task forever. And this is defined in the task class. And the third one is going to be what's so-called a callback function. If you are familiar with callback functions, then you will have a mean to, or maybe it will make sense to you. Why do we use callbacks in parallel programming? Okay, but if you have no idea what a callback is, it is simply a function that is going to be done in the background. Okay, like for instance, the CPU is doing something, and in the background, the callback function will be doing something else. That something is going to be done whether your CPU is doing it or not. So it will be always called in the background. So this callback function need to be passed by reference. We use this symbol for it, and then we can call it whatever we want. I'll just call it send callback. And this send callback need to be defined before it is called. Then, and it has to be of type void and taking no parameter. This is important to note. Then we can use the send callback, and then we define it in here. Actually, the setup and the loop, in the setup and the loop, we will have the minimum amount of of codes, everything has to be done in the callback functions. Okay, so let me define this send callback function and see what it does. At first, I want to use the serial monitor to see if I am getting into this send callback or not. And remember, we will be doing this every second. Every second, we will go to this callback and send some information. I will start off by serial print, maybe an empty line first. Oops. Then serial, the print line, start sending, to know that we have started the process, the sending process. Then actually we need to define first the variables for our ADC reading and the LED state. I will say just int LED state and the ADC reading. They are both of type integer. And go, we need to read for this one, we need to read the value of the potentiometer, okay? So we can simply use the analog read function. We say ADC reading equals analog read, and we pass the pin, okay? So I want also to print the value of this reading, say ADC value equals, then serial the print line ADC reading. Okay, now I have everything back, but I need only to serialize it and then send it back to the whole network. The serialization process, first we need to go and convert this information into a JSON format. And basically, to have a better understanding of the JSON format, I'll show you in this way. The JSON format will have an opening and closing curly brackets in this way. And inside these curly brackets, we'll have something called the value. Maybe I'll call it the ADC value. And its corresponding key, and in our case, is going to be ADC reading. Okay. Simply, if you think of this as a dictionary, when you go and try to find the meaning of a word, you will maybe go to find the meaning of the word maybe eat. Eat is going to be replaced by this ADC value, and whatever description in here is going to be its key. This is the way that JSON format works. This is the JSON format. So let's go ahead and try to define our JSON format type. To do this, we need a string. Actually, the serialization process, you will take the JSON format and then serialize it and send it as a string message. So for this string, we'll call it a message. And then we start the process of creating our JSON. To do this, we have what's so-called dynamic. It's going to be a bit long, but it's okay. It can be remembered easily. JSON document. Okay, dynamic JSON document. You can call it whatever you want. I will call it simply doc, and then give it the size, the buffer size, to 1024. Okay. Then we need to add to this document the value and its corresponding key. In order to do this, you can imagine this, if you are familiar with arrays, you can imagine this doc as an array. Like if you say maybe doc and index 0, then give it the ADC reading value. Okay, but instead of this 0, we will have the value, and our value is going to be the ADC value, and boom, we have it. Okay, so we have added this code, or maybe this entire thing, to our JSON document. Now we need to serialize it and copy whatever in this document to our message. To do this, we use the serialize JSON method. We pass the document and the corresponding message. Okay, now we have everything backed into this message. We need only to send this message as a broadcast. To do this, we use something called mesh.send broadcast. And we pass the message, and then we are done. Okay, so let me maybe serial print to show that we have sent our message, saying that message sent. Okay, so this is the sending part of this information. I need to define some parameters in the setup. I'll define start the serial connection to my laptop with the baud rate specified. You can change this baud rate to whatever you want. I need to define the pin mode for each one. Actually, pin modes in Arduino, they are by default they are considered as inputs. So, for instance, our potentiometer is going to be input, LED is going to be output. I can skip the definition of this potentiometer, but it will be much cleaner for any programmer to see which pin mode you are using. So our bot is going to be an input, and the LED is going to be an output. Okay. So now we can initiate the mesh by using the method called mesh.init, or initialize the mesh network, and then we pass the information in this exact order. First, we pass the ID and the password we have defined at the top, this ID and this password. And then we pass our scheduler by reference. Where did I go? Yeah, in here. Okay. I'll pass this by reference. Then I say my scheduler. And then simply we pass the port. Okay. So by this way, we will have the mesh initialized and everything is ready for us, but we only need to add the task we have specified with this callback function. This task has to be added to our scheduler. In order to do this, we use our scheduler and the method called add task. And then simply we pass the name of our task, and it is the send task. Okay, send task. And then we need to enable this task. We use its name and simply use the enable function. Then inside the loop, we will use something called mesh.update. And this mesh.update is taking care of everything we don't have to think of. And that's why it is called the painless mesh. Right now, the code is ready to send information to our mesh network. However, we need to define also the receiving part. Whenever we receive messages, what to do. First of all, we need to define another callback function. Maybe I'll call it received callback. The function is going to take two parameters. One of them is going to be the unsigned integer 32-bit number that is going to represent the chip number we are taking from the information. And this is the data type of it. Maybe I'll call it from, to know this is going to be coming from this chip. And simply the message or the content, and it is going to be of a type message. Okay, so we have defined this string message. We need to deserialize this message because we have in the sending part, we are serializing the message into JSON format and then sending using this mesh.send send broadcast. Then this will be done in every node. So we need to receive the message and then deserialize it. But before deserialization, let me just print the message and see what is the content of this message. I'll use the serial.print message equals dot print line, simply the message. Let me just add an empty line. Okay. So now we go for the deserialization process. This deserialization process is going to have the same almost process that we have done in the serialization. We need also the string, and the string is actually ready for us. It's in the message, but it is better to define another string. I'll call it simply JSON, and this JSON is going to equal to the message, the C string format of the message, and we can convert it using the C underscore star str. Then we also define the dynamic JSON document again, and I will call it doc and give it the same buffer size. Okay, now we are ready to deserialize, but in order to make sure that the deserialization process went successfully, we'll use something called deserialization error. It's too much to remember, but it's okay, it's easy. This class is going to define if there is an error with the deserialization or not. I'll have the object called error, and then equal this to deserialize method, deserialize JSON method. Simply add the doc and the string you have created. Then let us check if there is any error or not, and if there is any, print out the error reason. Okay, failed deserializing. And then serial the print line. Take the C string format of this error. Okay, so after this line, if we are not in the if part, that means we successfully deserialized the message, and the deserialized message is going to be in the document. It is going to be saved in the dynamic document. So as we said before, excuse me, as we said before, this node is going to take the button state and save it into the LED state, which is defined in here, and simply write this LED state to the LED bin. So we simply say LED state is equal to doc. Remember, think of this as an array. You will give it only the value. The value, maybe I'll just call it the button. Okay. And then, yeah, whenever the second node sends the button state in this value, this doc, this definition actually is going to give us the value of whatever button state is there for, and then assign it to the LED state. Then we simply use the digital write method to write this to the LED and say LED state. Okay. So we have this void function ready for us, the callback function, whenever we receive a message, ready for us to deploy. We need only to add this function to a method called the onReceive. Whenever we receive function, whenever we receive whenever we receive a message, then we need a callback function to handle this, and we pass it by reference. We pass our received callback, and then, yeah, This is the whole code that is going to be used for this first node. So let me connect this first node to computer and upload the code and see the output. Bear with me, I'm connecting the USB. Okay. We have the board. Oh, I'm connecting my phone. Let me take it out. Okay, it's COM9. The device type, I'm using Wemos D1 Mini for the first one. And then the upload speed to maximum. Hopefully we get no errors. Let us check. Oops, we have this R to be capital. I'm sorry, guys. I'll be checking the participants from time to time to admit the participants. Oops, another typo. It's a bit taking too long to compile, but this is normal with ESP. If this error comes to you anytime, then simply hit the upload button again and wait for it whenever it comes to you. And usually this is happening to me whenever I'm using the Wemos D1 Mini. I don't know why. Okay, uploading. Done. Let us see the serial monitor. Okay, now we are sending the value. Now I'll be changing the potentiometer reading. As you can see, it is changed. We are start sending ADC value message sent. Note this one is happening every second. Okay, this one is happening every second. Let me maybe even connect my phone and show you how am I changing the potentiometer reading. Just wait, bear with me. Okay. You are not seeing the, sorry, you're not seeing the COM board screen. This is the COM board, this is the output of it. Let me clear the output and see. And here is my phone. This is the one connected. When I change this one, check the values in the background of the COM board. It's only rotating. You see? So this is the way. Okay. So the first code is ready. Let us go and create another code. And basically, I will be using the same one and just modifying the code for the other nodes. So let me copy all of this, create a new one, share this screen with you. Okay, and then paste it, save it as second. Okay. So we have the same thing. This has to be the same for everyone. We don't, for the second one, instead of the potentiometer, we'll have the button. And the button is connected to D3, but the LED is connected to D5. Okay. I'll change this to a button state. ADC reading is the same thing. No, I actually I don't need the ADC reading. I only want to send the button state. Same thing, we have the scheduler for the mesh to use it and for our tasks to be added to it, and then simply the mesh class. We have this callback for our send task. Also the same thing, I will be sending this task every second. And the send callback, I want the LED to blink whenever it is start sending and whenever it finishes sending. So I will use the digital right LED to high. You can use also true or maybe simply 1. And at the end, whenever everything was done, then I'll just set it to low. I'll show you in action how this is happening super fast. Okay. And now we need to modify some parameters in here. Instead of reading the potentiometer, we'll be reading the button. Instead of analog read, it is digital read. This is going to be saved in the button state. And we change this one. Button state is equal to, change this one as well. Button state. Then we serialize everything, but we need to add the value of the button state instead of the ADC value, and simply pass the key as our button state. But if you remember, we have used, instead of button state, we have used the button in the receiving part. We have used it this way, so we need to use this button. So I'm removing this word. So it's the button and then serializing, then sending the message, and do this. So for the receiving messages, we are not going to take any parameter for this case. So I'm commenting this one and that one. It's okay if I deserialize it or not. I only want this message to be shown to me in this line. That's it. I deserialize it or no difference, because I'm not going to use any value sent by any node. Same thing, but we need to change this to the button. Initialization, on receive, add task, and enable. Everything is the same. So now we are ready to connect the second node and upload the code and see what outputs we get. Let me connect it and upload the code. Okay, now I'm connected. Let me share the whole screen with you first to see the output. The COM port is going to be, that one was COM, what was it? Was it COM 9? Let me remove it. Yeah, it's COM 11 right now. I need to change this to the NodeMCU 1.0. This is my second node. This one to 3000, and upload the code and reconnect that one. So COM 9, not to forget, COM 9 is the first node, COM 11 is the second node, COM 3 is my phone. I need not to forget this. Okay. So uploading. Now let us see the serial monitor. Okay, now we are sending the button state. Let me share the screen of my phone. Just wait for it. Okay. Right now, If you can see, this is the blinking part. Whenever it sends, it goes high and then goes low whenever it finishes. You see how fast this is happening. And if you look back in the background, you'll see the ADC value sent by this node, read by that one actually. This is the serial monitor, and this is the button. When I press it, check this LED. You see it goes off because whenever I press on this, this will go uh, to 0. Okay. So we have the first node and the second node in action. Let me use the Tera term because in serial monitor you can have only one COM port connected to it. So let me use the serial. I'm using this Tera term console to display both information sent and received by both connection. This COM9 is going to be our first node, but we need to set the correct baud rate. You see, these are the common baud rates used, but I'm using this one. And let me add another one and use this COM. All right. Let me just reset that one. No idea why it is giving garbage value. Okay, now. Right now, they are both sending. Let's wait for them to connect to each other. This one is sending the ADC. This is the first node. This is the second node. Let's just wait. Okay. Right now, the ADC value is being read. This is the second node, taking the value from this node to that one. This is the JSON format. If you can see it, the opening curly bracket, the closing, the value, and its key. Now, if I press the button in this way, you'll see it is going to 0, and that one will press will have this in 0 in here. So I'm pressing it now. This is 0. This is again 0. You see? So now we have seen both of them in action. Let us go and simply do the third node. Okay. Let me create a new Arduino. I'll just copy everything in here. Okay, paste it and save this as third. Okay. So again, we need to modify some small things in order for this to be running. We don't need to read any value. We have only the LED connected to pin 5. These credentials has to be the same. We want to read both messages. We want to read the button state and the ADC value. Okay, or maybe the ADC reading. We have this scheduler, this painlessMesh, but for this one, we are not going to be sending anything. So for this, I will be commenting all of this task thing. But remember, even if you don't want to use any task, the scheduler has to be defined for the mesh. So also, let me just remove this first. I'm commenting all of this. Okay. Now our work is going to be done in the received callback. We'll have the message displayed, then deserialized, and then in here we will be doing something. So in the button state, you remember this one is going to read one message at a time. So it either could read the button state or the ADC reading, but in both cases we'll include this one, otherwise it will assign 0 to it. We'll use the same one we have used before, the button information, or if it was coming from the first node, we use the ADC reading and use the ADC value. Oops. Okay. So now we have either the button state or ADC reading. Suppose that the first node, which is the one sending the ADC value, has come first. The ADC reading is going to take the value, whatever the value is sent, but the button state is going to be 0, and vice versa. Okay. So now we need an if statement saying that if, okay, if the ADC reading may be greater than 300, or the button state is 0, okay, toggle the LED. I want to toggle the LED. I use the LED, or simply pass the button state to it, maybe. No, let's just toggle the LED. Digital read. Oops. Whatever state is in there, we just toggle it. Okay. So this is the thing we only need. This is the only thing we need to do in this node, but we have to comment this out as well because we have no tasks. And then let's upload. Let's first connect and upload the code. Stay with me. Okay, now the third one is connected. NodeMCU, but the COM port is COM10. Let me upload the code. First of all, let us see the ADC value now. Let me share the whole screen with you. Okay, the ADC value is 543. That means it's greater than 300. What is it saying? Oh, this is reading. You see now the ADC reading is actually greater than 300, the one that is being sent. So this one is done. What is this button? Oh, we need to comment this as well because we don't have a button. Yes, Ahmed, you may talk. Unmute and Ahmed Amir, you raised hand. All right. Now we are done uploading. Let us see what this COM port is sending to us. By the way, this term is free to download. You can check for it. Okay, you see now the button readings is 1 and the ADC value is 543, 542. Let me even add the third one for you to see all of them in action. Okay. All right. Let me also bring up my phone. All right. You see, this is the first node sending the ADC value. That is the second node sending the button state. And that is the third node taking the information of both to toggle this LED. You see, as I told you, the message is going to be received one at a time for this LED. Okay, so either the ADC reading is going to be sent or the button state, but the button state is going to be 0, and that's why we will have this LED blinking. And if the ADC reading is greater than 300, then we'll be having when we receive the ADC reading message, this LED will be blinking. And you can see it's almost blinks in a 1 second manner because it's received this every 1 second. So now let me change the button state. This LED is off. That LED is blinking faster because the button state is always 0. If I remove it, this goes back to on, and now the blinking part is going to be every 1 second. Let me change the ADC value to something less than 300. Now the LED is taking a bit longer. Now take it back. All right. So all right. So now we have seen all 3 nodes communicating in action without the need of connecting to Wi-Fi. Remember these credentials, we have created them ourselves. It can be anything, and the board I have used the default one. But I need to note this, that this project this is not the end of this project. You need to upgrade this project to connect one of the mesh nodes to Wi-Fi and then communicate with the router and then make some IoT applications. But this simply is actually useful for indoor application if you don't want to connect to Wi-Fi, and you can have as many as you want mesh nodes, up to 87 as the ExpressF company claimed. And this is going to be the, let's say, the end of this session. Right now, we'll be having the Q&A session, and I'll be checking also the chat if there's any questions first, and see. If you have questions, you may unmute and then ask. Otherwise, I'll check the chat session. ADC reading, you forgot DG. COM10 was for the 3rd node, which is the one blinking the LED according to both values. And yeah, it's correct. It's the third node. Anyone has any questions? Please unmute yourself and talk.
Sorry, when you define the board 5555, how do we know the board? Did you change it or you put it any number you want?
No, actually, I'm using the default board. You can also use any board. Maybe if you want, you can use 888, whatever it is. But it is better to use big numbers. And I use the default one. You can change it if you like.
Oh, thank you very much.
You're welcome. Please, if you have any question, unmute and speak, or send in the chat.
Hello, sir.
Yes,
I have
sir.
a question. Yeah, how did you connect the nodes, the 3 nodes in the code and in the physical hardware? Like, I couldn't understand it in my mind.
Okay, let me.
Can you?
All right, let me just show it to you. Just bear with me. Let me share my screen and open up my phone. Okay, first of all, okay, oops. First of all, these all nodes are connected through, they have these small antennas, if you can see them, these gold ones, they are antennas actually sending information, okay? They are connected wirelessly. They are not connected in a wire manner. They are not connected physically. They are connected wirelessly through the sending information and receiving, okay? So These are connected to my laptop using USB cables. Actually, I haven't shown you. Maybe I need to. It's connected to this hub to my laptop. I'm in the serial or the TerraTerm console. You can see all of them at the same time. All of the messages being sent to my laptop through this cable, but they are also sending information through this antenna to all other nodes. They are connected wirelessly. I hope this answers your questions.
Yeah, much better. Thanks.
You're welcome. All right, any other questions, guys? Please unmute. If you want me to go over the code again to remember if you have questions or something. I'll wait for a couple of minutes and see. Also, regarding the next session, I'm revealing some of the information. You will be able to control the devices and the circuitry from your place using your mobile, using an application. So stay tuned to see that. And remember, it will be on 22nd May, 3 days from now, inshallah. If you have any questions regarding the hardware, the coding, or maybe anything, please let me know. Or you might
Sir, I have a question about the first session.
Yeah.
On Friday, maybe that happened before 2 days, something. I missed it. Like I didn't know about the announcement, so I think, are you gonna upload something for that session?
Yeah, actually, we are recording all these sessions, the video, and this video is up to now recorded. We'll be uploading the videos to our website, and we'll share also with you some documents, supporting documents and resources for the last session, hopefully by tonight, if not by in the coming couple of days. The same for this one. We'll be sharing this with you in the WhatsApp group if you are in. If not, then we'll be sending this information to your emails. And remember, for the third session, also you need to register again to not have conflicts, because I think some people from the first session, they thought one registration is enough, maybe. So I'm telling you, you need to register also for the third one when we announce it. Go please and register.
Okay, cool.
Do we have any other questions, guys? All right, then this wraps it up for this session. Thank you so much for attending. I have taken a list for those who attended in order to give them certificates. Big thank you to be patient up to this point. I hope you found this useful and joyful. If you have any questions, you might use our email, our team's email, emuaquabotics@gmail.com, or you might contact us using the WhatsApp group before it gets deleted. Thank you so much for being with us today, and we'll look forward to see you in the next session, inshallah. Thank you all.
Thank you very much for your
Thank you, sir.
You're welcome. You are welcome, guys. Take care and be safe, please.